All right, so today's kind of a review, so it's more for you guys if you guys have specific questions. I've got a couple things that we'll work through, but unless there's additional questions, we'll kind of stop wherever those questions stop. But just to kind of mention a few things. So the exam's up there and currently open on Canvas. Like I mentioned, that was going to be available late afternoon. Ended up opening up at 5 yesterday. So it's 17 multiple choice questions. Each one's worth 4 points, total of 68 points. There's then 2 short answers that have multiple components. The total is 32 points from those. So it's about 30% of the exam comes from those short answers. So if you're working through these, make sure you save an adequate amount of time to kind of work on those short answer questions. You'll upload your work. There'll be a file upload question, so you can either upload, pictures of your work. That works fine. I said you can scan it, but that takes some time. If you don't have something that's readily available to you, that might not be a very viable option. But kind of taking pictures of your work is adequate, or doing it in Word and uploading the Word document, doing your work in Excel, upload the Excel document. All of those are how you can show your work. Okay. Make sure you show as much as possible, because the goal of those short answers is for me to give partial credit on those questions. I'm not giving partial credit on the multiple choice, so you don't have to show your work for those, but for those 2 short answers and those file uploads, make sure you show your work. There'll be an hour and 20 minutes once you start the exam to kind of complete and submit it. There's 1 bonus question, so it'll look like the exam is worth 104 points. It's only worth 100, right? So you could technically get above 100% if you got every single thing correct. Okay. There's no lockdown, so you'll be able to have Excel open and use that. You'll be able to use your formula sheet, all other kind of resources available to you. I asked, I can especially with the short answers, uphold kind of academic integrity. If I see something that looks a little suspicious, I'm probably going to kind of reach out and kind of call you out on it. Other than that, are there any questions specifically about the exam? I know we talked about it a little bit before, but that's kind of the exact specifics of it. We'll wait to see if there's anything on chat that comes up.
So for the multiple choice
Yep.
questions, so the showing our work isn't necessary, right?
Nope. So the only part where you have to show your work, and I'll be kind of grading it based off of the work I see, for any partial credit would be those 2 final short answer questions. And they have a couple A, B, and C to them, but the kind of total of those questions. Yeah. So, I would suggest that you're still doing work for the multiple choice questions, right? But you don't have to show it, and there's kind of no partial credit given for those questions. Any other questions on anything like that related just to the kind of mechanics of the exam? No? Okay. Just some other resources I want to make. Yeah. Yeah, so they'll still be like math. They're going to look like similar to problems you saw in the practice exam. They're just left open-ended, right? You're not given 4 options, and so there you actually have to kind of show like how you're working to that final answer. Yeah, they're not going to be. It's not like some of the questions maybe on the Excel where there's like interpret this, or they're still computational, but it allows me to give a little bit more partial credit for those. There's some that I think they're a little bit more difficult. And that you could be a little bit off in how you're doing it, and you get a completely wrong answer, but you were really, really close to like having it worked out correctly, right? So that's kind of the ones I chose for the short answer. The resources I wanted to make available or make you aware of, I mentioned this, but I put up a more detailed answer key to practice exam B. So this uploads. Kind of see, I've kind of typed out every single answer, even identifying what formula you should use and then kind of how you would work that out. So that's up there on Canvas now for practice exam B, just to give you a little bit more kind of study resources there. And then I hate that Zoom drops down there, so I go to grab the bar. On our playlist, so Monday and then Wednesday, the video I posted, and some of you kind of watched on Zoom. Let me see. So here's what we did Monday, right? Questions 5 through 9 and 14 through 17 on practice exam A. I then did 10 through 14, 18 through 20 on practice exam A. Kind of leaving off, the only questions were the 1 through 4, which are some of the easier stuff, like kind of finding a mean, which if you do want to see problems like that worked out, here are these practice exam B problems. If you click on it, the description, nope. I just want to pause it. Oh, what was that? I clicked on the wrong one. Practice exam B. I kind of worked through basically 1 through 9 and then 14 through 20. And then 11 through 13 are here in this separate video. So basically, between all those videos, you have nearly every question on these practice exams. You can observe me working through them. So if you have any specific questions, and when I typed them like this, the reason why I didn't say 1 through 9 is because this is the order in which the video, I start with 5, I go through 9. It kind of keeps the order, so it's a little bit easier to find exactly where I was working through certain problems. Any questions on any of that before we kind of jump into a couple more things I think you might want to know, wink, wink, before going into the exam? Okay. All right, so let's look at practice exam A for a second. And something that we didn't cover that I want to make sure you're aware or you would know how to do. Okay. So let's say we have this kind of contingency table set up, and we work through a bunch of different problems that we could be asked about that. But one thing that even pops up in the Excel that is kind of that Excel and connector due by the end of the day today as well. I have a lot of people have already uploaded those, like I suggested, kind of working on that early, so that's good. But one of the questions in there and that we worked through in class that's not on one of these practice exams that you will be and likely be expected to know on the exam, and I wrote the exam, so take that for what it's worth. So we've got this contingency table. Just to keep this up here for a second, let me see. I'll make this real big. And I'm going to go to the dot cam real quick. So it might take a second to switch over. So we've got the events here of being older than 55 and when wanting marijuana legalized or not. So what if instead I had asked for what's the probability that somebody wants marijuana legalized, or you can kind of think about this as LM is equal to yes, or, right, they're Republican. So I could have asked you to find the union of two events, and you can use this contingency table to do that. So this could be a question that you're asked. So if we look at our formula sheet, and go up here, if we want, now, this isn't a special condition, but if we had the union of two events, right, we actually have kind of the names for the events here, not just A and B. You would add the probability of each event together, and then we said, well, we're double counting what's in both of them. What's in both of them, that's the intersection, so we'll subtract that out once, right, to make sure we're only counting at one time. So once we've identified this is the formula that we can use to find the union, let's just write this formula out in the context of our example. So this would be the probability of our event A, right? Our event is that they want marijuana legalized, plus the probability of our event B, what's our second event here, kind of being Republican. And then we would subtract the intersection of the two. Right? So to kind of shorthand this, I'm just going to use LM. I'll write the yes small here. I'll zoom in this a little bit. And the intersection between that and whether or not they're Republican. Okay? So all I did was write that out in the context of my example. Okay. Oh, also, you guys can see this big in class. I want to make sure that you can kind of see how I was plugging this in with the formula. There we go. All right, so I just wrote this formula out in the context of my example, right? I had the probability of A or B, so it's the probability of A plus the probability of B minus their intersection. Once I have that written out, now it's just a matter of using this table to find those probabilities. So what's the probability that somebody wants marijuana legalized? So we go here, yes, 0.66. what's the probability someone's Republican? Or sorry, why did no one ask me what the hell I'm talking about? This is for the other practice exam. I was thinking about this. So let's say, let's change this real quick. Sorry about that. Let's say older than 55, which just changes, right? Actually, this is maybe a good point, right? It doesn't matter what event we have, right? We're just plugging in whatever that event is, right? So sorry about that. I was thinking about the other exam has kind of the Republican or not, and this one's over 55, okay? So what's the probability someone's older than 55? 0.25 minus the intersection of, do they want marijuana legalized? Yes. And are they over 55? Yes. So 0.14. So what? This is going to be 0.09, so 0.75, if I'm looking at this right? No, it can't be right. It's what? 0.8, 0.91 minus 0.14, so 0.77. Am I doing that math in my head correct? I don't know why this shouldn't be so hard, huh? Yeah, 0.77. Okay. So, it's just writing out that formula in the context of your example, and then it's just using that contingency table to plug in those probabilities. Okay. Are any questions on that one since I started out kind of screwing it up for you guys a little bit? Anybody on Zoom? Okay. Sorry about that. The other one, it's not on here, but let's say, just go down to the bottom of this so I can type it out for you. So let's say I had some information like this. So the positive relationship between income and education is stronger, and probably on the exam I would do something like stronger than the negative relationship between test scores and hours of Netflix watched. All right. So if this was a multiple choice, I might give you some potential answers. Or if we can think about, even if it wasn't multiple choice and I left it open-ended, what are some possible values that the correlation coefficients could be for these two things? So this is kind of what we were given. I'm going to switch to make this full screen for a second and kind of think about some of the properties for the correlation coefficient. So when we talked about these correlation coefficients, the way we write them is it was this Greek letter kind of rho. And here we'll think about between income and education was the first thing that we were thinking about the relationship between. And the second one was what? Test scores and Netflix, right? And if you wanted to write these words out, that's fine. I'm just kind of shorthanding using the first letter. So what are the possible values that these could be? Okay. Well, we were said that the relationship between income and education is positive. The relationship between hours of Netflix watched and test scores was negative, right? So right away, we know this has to be a negative value. This will be kind of a positive value. But we were also told that this was a stronger relationship than this one, okay? Well, first of all, what's the highest value I could see this correlation coefficient be? If we recall the discussion going back a bit. Yeah, right, the whole idea was we were taking the covariance and scaling it so that we could compare across different types of variables, right? So we said the correlation coefficient has to be somewhere between 1 and negative 1. Right? So maybe this is something like, I don't know, 0.7. Okay? If you see that this was 0.7, what do you know has to be true if this is a stronger relationship than this? Well, this one would just have to be closer to 0. Yeah, it could be something like 0.3, it could be something like negative 0.4, but what it couldn't be is negative 0.8, right? Because the closer this gets to negative 1, that's representing a stronger negative relationship between those variables, okay? So because we were told that the relationship between income and education is stronger, we know this correlation coefficient has to be larger in absolute value. Like if we ignore the signs, it has to be larger or closer to 1 than this correlation coefficient is close, or closer to 1 than this one is to -1. Okay? So we also could have thought about, if I see an answer that was 1.2, well, I could have ruled that out right away as well, because I know that the correlation coefficient has to be somewhere in this range. Okay? So thinking about kind of the properties of that correlation coefficient and being given the information that we did, that there was a stronger relationship between income and education, we know this will be closer to 1 than this is to -1. Okay? Any questions on that? Okay with that? Okay, so I'll open this up then. Are there any specific problems on either practice exam that you have questions on, want to see worked through? No specific questions from people here. What about anybody on Zoom? No, don't be shy. This is why it's kind of a review thing. So, we worked through the practice exam A, and so if there's any additional questions, I want to make sure I focus on the ones you have questions on. Okay. Well, let me think then if there's anything else that I'll kind of work through 4 with you. Yeah.
The lie detector one?
A Bayes theorem one? Yeah, so we did A, or we did practice exam A, right? So let's go through practice exam B's. It's slightly different, but it's the same sort of setup, okay? So let's say, we'll go to practice exam B here. Why isn't it letting me? Okay. So we'll go down here to problem kind of, you're probably thinking about 13. Right? So let's first start out looking at this problem, just identifying what we were given. Okay. So we've got all this information right here, right? And they're talking about the use of steroids and whether or not a test comes back positive or negative. So kind of like a lie detector test coming back positive. So what do we have here? They claim that a drug test will show positive given that the athlete is using with a probability of 0.95. So well, the dot can catch up to us. Essentially what we're told there is, I'll make sure you guys can see the wording here in class as well, since that's where the question was asked. Waiting for the screen, there we go. So we're told that the probability the test comes back positive, given that the athlete is using steroids, right? So given that the athlete is using, the probability the test comes back positive is 0.95. Okay? We then have the next thing that we're told is, however, the probability it shows positive given that the athlete is not using. So given the athlete is not using, the test comes back positive with a probability of 0.01. Okay. We're then kind of told that the probability that any player chosen at random is using steroids is 0.15. So 15% of the players are using. Okay. So those were the 3 things that we were given, right? The 3 probabilities we were given. Now we might have to solve for some missing ones, and I'll kind of come back to that because I don't think we need to in this example, and I'll just work through how we use Bayes' theorem, but then return to, well, what if this was the case? Okay. So we go down here to 13. These are the 3 probabilities that we identified. However, what the question in 13 asks us for is, given that the test comes back positive, what's the probability that they are not using, or that they do not use steroids? So first kind of step is we write down what we're looking for, and we realize this is a conditional probability. So we go to our formula sheet. Okay, I can solve for a conditional probability using this, multiplication rule, kind of simple problem. The issue is if I start to write this out, the probability of what I conditioned on, the probability of B, would be the probability that the test comes back positive. I wasn't given that, right? And so this was kind of a scenario where we have to break it down to multiple parts, because some people that see a positive test result will actually be not using, and some of them that see a positive test result would be using. So we had to break this down into more components, which was what we were calling kind of Bayes' theorem, right? This guy right here. So the way in which I would approach these problems is once you have this conditional probability, and it's, these formats are similar. So when you kind of get to, this part of the exam, you'll realize, oh, I was given some information. I was given some conditional probabilities. I'm wanting to find another type of conditional probability. So I probably have to use Bayes' theorem here. So here's our S and here's our E, right? That's how I would start out setting it up. Now let's just write this out in the context of our example. Yeah. Yeah, it would make a huge, sorry, when you say switched, what do you mean? Like if I had wrote an E here and S here?
Yeah,
Yeah, it would matter a lot, right? So it doesn't really matter what you call these, I guess. But if you flip-flop these, you would have to flip-flop the S and the E in every single place in here, right? So then it just becomes, now it makes it more hard to use this equation, right? The reason why I'm saying identify this is S and this is E is because I'm giving you this formula in the formula sheet that you can kind of follow that same pattern. Whatever's in the first, right, whatever you're looking for the probability of, we're calling it S here, that's what you're going to be putting right there. Whatever the outcome of the test you're interested in is, you'd be putting that kind of, you're looking for that conditional probability here. So it does matter in the sense that if you're going to use this formula on the formula sheet, keep that consistent, and then it'll make it a lot easier. Okay? So notice now if I want to write this out, the numerator is the probability of S. So my S is not using, so I'll just write probability of not using here. And I wish I could make this bigger. Let me see. There we go. A little bit bigger here. Times the probability of E given S. So my E is that the test comes back positive, given my event S, which is that they're not using. Okay? You see that okay? Okay. We're then going to divide by, now notice here, just to kind of sake of keeping these a little bit kind of cleaner down here, notice this is the same thing. The very first part of the denominator is the same as the numerator, right? Because really what this represents in the numerator is like almost, you could think of it as the number of people who aren't using but also get a positive test result, right? So that's kind of our first group. So it's going to be the exact same thing down here in the denominator. It's going to be exactly what we have in the numerator. So you could write this out. Just for me showing you, I'm going to kind of use these to notate this as the same, just so that I save myself some room to write this out. So we then add in the probability of S complement. If my event S is not using, what would my event S complement be? Yeah, just the other state of nature that they are using times the probability of E given S complement. My E was that the test comes back positive. Given S complement, we just said that that was using. And now it's just a matter of plugging in those probabilities. So what's the probability somebody's not using? We'll go back here. Well, we weren't directly given that probability, right? These were the three probabilities we had. But if I know the probability someone's using is 0.15, what's the probability that they're not using? Yeah, right? They're either using or they're not. So we know that's kind of like A and A complement, right? So those probabilities have to add up to 1. So what would get us up to 1? 0.85. Right? So 0.85 is the probability there. So 0.85 times the probability that given they're not using that the test comes back positive. So given that they're not using, the probability the test comes back positive was told to us to be 0.01. First part of that denominator is the exact same thing as the numerator. Add in the probability that they're using. We were told that was 0.15. Times, given that they're using, what's the probability the test comes back positive? So given they're using, the probability the test comes back positive. We identified that earlier as 0.95. And now it's just, simply kind of getting this entered into our calculator. Okay? And if I remember, I think this is, I might be thinking about the wrong exam. Just 0.056, yeah. Okay. So kind of the steps there were write out the probability you're looking for. Once you do that, just put S and E here. It might make it kind of simple so that you can. And that what will remind you to do that is, whatever's first is S, whatever's second is E. And then this form of the equation, just write that out in the context of your example. And then from the probabilities that you were given earlier in the problem that you used for, you used them for what, 11 and 12 as well. You're basically just plugging those probabilities into here. Okay. Does that help a little bit? Kind of just give another, okay. Now, one thing I'll mention here is this one was kind of easy in the sense that there was no missing parts once I got to this point. But instead, I had was looking for a negative test result, and we go back here. I'm going to move this just so there's nothing behind it. Zoom out a little sec first. Actually, I don't need to zoom out. Let me just do this guy. Okay. So similar to here, we weren't given the probability that they're not using, right? We had to kind of derive that from what we were given. Okay? As soon as I wrote this down, what I could have done, because if I had asked you a question like, given that the test comes back negative, well, we didn't have any of those kind of negative, but, right, I know that if I condition on the same state of nature, right, or I'm looking at people who are using, right, given that they're using, so it's almost like you're looking at a person who's using, because they're using, the probability the test comes back positive is 0.95. So that same person who's using then, what would be the probability that they get a negative test result? Well, it's the only other test result, so these have to add up to 1. Right? It's the same person who's using, they can only see 2 outcomes of the test. So if the probability of seeing a positive result is 0.95, the probability of seeing a negative test result is 0.05. Same kind of idea here. Let's say now, given that someone's not using, so we're looking at a person who is not using now, well, the probability that person who's not using gets a positive test result is 0.01. So the probability they get a negative test result would be what? Yeah, just 0.99, right? It's the only other outcome. So we know that conditioning on the same state of nature, the conditional probabilities of the 2 outcomes of the test, have to add up to 1. And now if I asked you a question like, given that someone's using, given that we see the test result come up negative, what's the probability they're using? Well, now it looks similar to what we did before, but now everywhere we have a negative or a positive test result before, we're going to have a negative test result, and we would have needed these probabilities to solve for that. So I'm not necessarily saying you'll have to do that in the exam, but that is kind of something that you could have to do, maybe find one missing piece or something like that. Okay? Any questions on that? Wait a second for the chat. All right. Any other questions over any type of problem or? No? Okay. Let me think of something else maybe we haven't mentioned that you would want to make sure you know on the exam. So first of all, anything that kind of Monday I said, anything that I said kind of the beginning on Wednesday or any of the problems I worked through, those would be good things to watch. Because if I did something in class, there was probably a reason for it since I wrote the exam like today. The reason why I went over that correlation coefficient review and making sure we know how to find unions using contingency tables, probably did that for a reason. Going over these Bayes theorem problems, another good one to make sure you understand kind of what we're doing there. Other than that, one thing that make sure you remember in these binomial, oh, and this one doesn't have a Poisson. I think it's practice exam A. So yeah, in these Poisson and these binomial problems, one thing to remember is that you may be asked for something that is a little difficult. So let's say we use a Poisson one where I say, on average in a year, I don't know, I was just listening to some Joe Rogan. So let's say there's like 10 UFOs that visit Earth, right? So if you have kind of the average over the year, then that's okay. Well, what's the probability that at least 2 or X is greater than or equal to 2 this year? So on average, it's 10. Well, what we said was we'd have to do, okay, what are all the outcomes that fit this criteria? So the probability X is equal to 2, plus the probability X is equal to 3, plus probably X is equal to 4, all the way to like, where do we stop, right? An infinite number of alien visits, right? So I can't really find this. This is not practical. But if I think about this as event A, always remember that there's probably an easier way to find something that where anytime you have more than 3 probabilities that you're going to have to solve for, like have to use the Poisson probability mass function more than 3 times, there's probably an easier way to do it. I don't want these to take you a lot of time, right? I don't want you to have to sit there and kind of enter in the Poisson distribution equation 4 or 5 times. So there's probably, or even the binomial, so there's probably an easier way to do this, which is, well, this is going to actually just be equal to 1 minus the probability of the complement. What's the complement to X being greater than or equal to 2? X is less than 2, which remember, we're dealing with discrete random variables here. So the only 2 outcomes that would fit this criteria would be X is equal to 1, and don't forget, X is equal to 0. Okay? So you should never be using those probability mass functions more than 2 times, for any problem on the exam. There should be something that you can kind of simplify it with, okay? So make sure you remember that. Make sure we pay attention to kind of equalities as well. For example, let's say instead on this one, I had said, what's the probability that at least 1 UFO visits? So instead of 2, we had 1 here. Well, then this would be the probability that it's less than 1. What are the only outcomes that would have fit in this criteria? Probably you would have only had to use that 1 time, right? You only have to use that probability mass function for the Poisson 1 time. Okay? Now some other things to review if we had used that, right? I've got my lambda of 10, my X is 0. So I'll go to the formula sheet and show you where that Poisson distribution equation is when we're done here. But it's lambda to the, well, I'll write it out for you. Lambda to the X, e to the negative lambda over X factorial. So 10 to the 0, e to the negative 10 over 0 factorial. Remember, 0 factorial is 1, and also anything to the 0 power is 1 as well. Okay? So this actually just kind of simplifies to e to the negative 10. Okay? Any other questions about that? I'll share screen, and then I'll leave this up here if you want to kind of see that. Because I wanted to show you that Poisson distribution equation is all the way down here in the bottom right-hand corner. Okay. And then here's the binomial stuff, right? Here's our binomial probability mass function. So how do we identify the difference between the binomial and the Poisson is probably another good thing to know. So what's the difference in the examples of those two? Well, what's one thing that we have in this probability mass function that we don't have down here? This n, number of trials. So anytime you have a question where it's something like, what's the probability 10 of the 15 people, right? Or you're looking for a certain number of successes out of like a finite amount, a capped amount. The most I could ever see here is 15 people. As opposed to our example here, where it's, well, where does this stop, right? I'm looking for, more than 2 successes, but the, 2 successes out of what? Out of nothing, right? It's open-ended. It's over an entire year. So theoretically, I could see, an infinite number of UFO kind of visitations, right? Because I'm looking at a time interval as opposed to like a finite capped amount of trials, okay? So anytime you have kind of a maximum that you could see, think of, the number of successes, think about that, that's your binomial. Anytime it's open-ended or you just have a time interval you're looking for the number of successes for, that's a Poisson, okay? So I don't know if this helps to have like kind of something to remember that by. I said it in words, so hopefully, it's always good to take notes, but I think if I was taking notes, this was what I would have written down, right? So anytime I can see like a maximum number of successes, that's my binomial, right? I ran out of room and I wrote really sloppy. So anytime I'm looking for a number of successes over a time interval, that's my Poisson, okay? Might be a good way to kind of keep those straight. And one thing you could do, I would suggest this. I mean, this is less to do with this class and more of just like a good study thing. I gave you this formula sheet, right? And I said it's probably good to like write down next to it what these functions mean. Like maybe I go here and this is the binomial standard deviation. Maybe I make the font smaller so I didn't have to do, not write the whole word out. And then, here I'm like, okay, this is the Poisson or, however I want to do this. I could print it out and write it down. But maybe, this actually, if it's in the Word document or on another piece of paper, I would start putting these things that I'm saying about that they're, good things to remember. So maybe down here you write, max number of successes, right? And you kind of write that out so that you kind of have that there. It's almost like a cheat sheet, right? So, you're allowed all kinds of resources for this, so why not create your own cheat sheet as well, okay? Any other questions? Okay. I mean, those are kind of the things that, I can think of to mention some last minute stuff before you go into the exam to go over. Kind of want to make you aware of those additional video resources that are up there on the YouTube page and kind of the specifics of the exam. So if there's no more questions, where are we at in time? We'll probably be out a little bit early today, unless anyone has any last minute kind of questions for me. Anybody on Zoom? Quiet bunch today. Okay, so if you haven't, I would go back and watch that video that I recorded and posted Wednesday. That's just me working through some more of the problems from practice exam A. I think that'd be a good thing to make sure you watch or use as a tool as you're working through those on your own. If it was me, I would first kind of start out going over the practice exams, make sure I have a good understanding of all those, make sure you kind of anything that we talked about additionally, not on those exams, the last 3 classes or over this week, you kind of review those problems as well. And then from there, I would maybe go back, look at, some of the online quizzes, maybe go back to some of the problems that we worked through in class. If you want to, a lot of the videos are, have descriptions that are exactly what we covered. So if you're looking for a specific, type of problems, kind of go through those, find that video that goes over that topic and maybe review some of that. Okay? So that's one thing I would, this whole COVID thing has been terrible and it's not fun. It's fun to teach and it's not as easy. But I also think for you guys, having those additional resources when you're getting close to exams to go back and be able to watch through things and kind of hear me talk about it again is also a good resource that most semesters you wouldn't probably have. Okay? All right, well, if there's no more questions for me, I will try to check my email kind of today and over the weekend. I may not be able to respond, immediately, but I will periodically check it if you have any last minute questions. Email me at 11 o'clock tonight, you're probably not going to get a response till tomorrow. But for the most part, I'll periodically check and try to get some responses out as fast as I can. Okay. All right. Well, good luck, and I will see you guys on Monday.